sounds good. I think we're good to go. Guys, how are you? Good morning. My hope is that you're actually not watching this, that I'm actually in the classroom with you, but just in case, I recorded this just in case something happened with my flights on the way home. So that's kind of why I'm doing this, and I do appreciate your guys' patience here on this today, because I did intend to be there in class today, but if you're watching this, I clearly am not. So I'm coming at you here from an Electron, but what we're going to do is we're going to review those quizzes. So if you'll remember the assignment before Memorial Day, it was that you are supposed to have brought back the quizzes that you guys took, and I hope that you can all produce them right here this morning, because we are going to go over them and we're going to review, because you were supposed to bring them back without error. Okay? So we're going to discuss that here today as we get into the quizzing process, and with that we'll start here in the book at the kind of at the very beginning. Let me hold on to this, change that, there we go. I'm looking here, I'm just showing, wow, okay. I just got an update here talking about delays on my flight, so maybe it's a good thing I'm recording this. So anyway, there you go. So let's take a look here at the first question that I ask. And the first question I ask is, what is the difference between a towered and a non-towered airport? So let's talk about that difference between a towered and a non-towered airport. So if you look at this, I mean, clearly the difference is that one airport has a control tower, the other one does not. Duh. So what I'm looking at for here is to see what are the primary differences and to list what those differences are. At a towered airport, you do have someone there from air traffic control, and that is going to be someone who will verbally shepherd you with some form of orderly airflow, traffic flow around that airport, and they are responsible for helping to maintain separation of aircraft while they're in that airspace that is kind of governed by them. Normally it is a pretty narrow range of where they are. I'm not 100% sure quite what that parameter is, because I think it depends on the different types of towered versus non-towered airports. But you realize that Class Delta airspace is going to be a smaller geographic area, Class Charlie airspace will be even bigger, and then Class Bravo airspace will be even bigger than that. So when you look at that, oftentimes you're talking to approach, you're talking to departure, and then they hand you off to the tower as the case warrants. And that is one of the functions there of the control tower. So it really kind of depends. It's a little bit narrower, in and around Class Delta airspace, which is what Aspen is. And, it's going to be a little bit of larger airspace, clearly, in Denver. So that's going to be part of it. Another piece has to do with the non-towered airports, is the fact that if there is not a traffic tower, then pilots themselves are responsible for the ground and airflow around that particular airport. So you're going to have a frequency, or a set of two frequencies, in most cases it's just one, that you, what we call, self-announce. You say to the people there what your intentions are, how you're going to taxi, what runway you're going to be using, what your departure plans are going to be. If you're arriving at the airport, you definitely want to make sure that you announce your intentions at least 10 nautical miles away from that airport, and that as you get in, you're giving periodic position reports. You are not jamming the airways with chatter, but you are giving your position reports, especially if there are other potential conflicts there around that pattern, somewhere around that airport that you can hear. If someone is out there in the traffic pattern doing touch and goes, whatever it's going to be, or if somebody else is coming in from the west, you're coming from the east, you need to kind of know where they are, and you'll state your position, your altitude, and your intentions. That's normally what you're looking for. You use the Common Traffic Advisory Frequency, which is that thing that all people are going to be using there in that area. Now, here's one of the things, is that if you look at the paragraph here, and you look at the information about what a towered airport is here, and look at what a non-towered airport is here as well, it is, you can see that there's quite a bit more to non-towered airports than you might expect. And that reason is because now the majority of the responsibility for the safe flow of traffic is up to you. And that is a responsibility that you do not want to take lightly. So that's what you do. You dial up a frequency. It's important to make sure that you're on the correct frequency. A lot of the frequencies for the Common Traffic Advisory frequencies for small airports are going to be 122.8, 122.7, 122.9, somewhere in there. And what really makes it kind of confusing is the fact that you may have another airport, especially in flatland countries, that you may actually be able to hear another regional airport, another small non-towered airport using the same frequency that you may be using. Well, now what? How do you do it? Well, it's how you begin your communications. So you'll start with, for instance, Rifle, Garfield County. Rifle traffic, Diamond Star, 141 Hotel Lima, 10 miles to the east, inbound landing runway 26, Rifle. So you say Rifle at the beginning and you say Rifle at the end. Because if for whatever reason there's another airport nearby that's using that same radio frequency, you don't want to be confusing other people or confusing people there at Rifle. So that's kind of how you do the self-announce. You begin with the name of the airport that you're flying to, and you end with the name of that airport. So that's one of the ways that we do it, especially when there are several frequencies there that are several airports that are very close in that frequency. Okay. Next thing is, what is traffic pattern altitude and how high above the ground is it? Traffic pattern altitude, or TPA, traffic pattern altitude, normally is going to be 1,000 feet AGL. So that's what you should have there. It's not always the case. In some cases, you're going to have altitudes that are going to be based on the type of aircraft that you fly. You may have a small piston single that is going to be at 800 feet AGL, and you may have turboprop aircraft at 1,000 feet AGL. You have to look in the chart supplement guide or in ForeFlight for the operations for that airport to find out exactly what criteria there are for traffic pattern altitudes for that airport. So in Aspen, for instance, we're almost at 1,200 feet above the runway is where we operate, because our traffic pattern altitude there is 9,000 feet. The runway, the takeoff end for runway 33 is about 7,800 feet. The approach end for runway 15 is about 7,600 feet. So we're a little bit higher than that. Why? Well, it's because of all those rocks that we have out there around Aspen. So it's a little different deal. Plus, the actual flow of traffic is also going to be outlined in the chart supplement guide. It's a green book. We used to call it the Airport Facility Directory book, but we call it the chart supplement guide now. So that's the question that you have there. Next, what is ATIS? How do we get it? Is it required for us to use? And what information does it give us? So if we look here, let's get over here, and we're going to come back here to this airport piece, but I want to get over here to ATIS. So one of the things that we want when we're coming into an airport is that we want the weather. We want to know what are the winds doing at that airport? What is our visibility? What are our sky conditions? What's the temperature? What is our altimeter setting? And those are the things that we normally get here. It's like a METAR. It's why we looked at those and why we memorized the format for METARs. Those things can be given to us in an AWOS, AWOS, or a SOS, ASOS, and that can be done electronically with an automated computer that may be located there on the field itself. So those are things that we get, and we get those updates almost every 30 seconds. It is just a loop, and if anything changes, the information changes. Then there's another thing that we get primarily at towered airfields called ATIS. And ATIS, as you can see here in the materials, is the Automated Terminal Information Service. And what we get with that, we get weather information, plus we get operational information about the airport itself. So we get the same type of a readout that we get on weather, and these are done once an hour. So when they're produced, the weather there is going to be pretty accurate, but then over time, you know, as the minutes tick by, if you're getting the ATIS 45 minutes after it has been recorded, chances are you're getting a stale forecast. So we need to know, when is this ATIS produced? We know that a lot of them are basically produced at 7 minutes until the top of the hour. So if we're flying into an airport and we're 10 to 12 nautical miles away and we pick up the ATIS and it is, 6:45, let's say.
It's 18 hours.
Well, thank you, dear. We know that it is going to be a stale forecast. So we would expect then the tower, because that's where you get most of these ATIS from, is from a towered airfield. We would expect the tower to give us the updated altimeter setting and the updated winds. They normally aren't going to give us temperatures with things like that, but they may. And if temperatures, if conditions change often enough there, in that hour, there will be a supplemental ATIS that will come out. So if the winds change a bunch, if the temperature changes a bunch, if it starts snowing or raining or whatever, and the conditions warrant, they will issue a new ATIS before that next hour comes up. So with that, the one thing that you kind of need to know is that it changes, and there's a name to it. So with each one that they do, they will name it something. So they'll start, it depends on who's starting the thing in the morning. They may start with Alpha, the next one, and the next hour will be Bravo, the next hour will be Charlie, the next hour will be Delta. And so they will say, Automated Terminal Information System, Aspen, 1553 Zulu, winds, blah, 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 visibility, blah, 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 sky conditions, blah, 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 whatever. And then they go through all of the METAR stuff. They go through the operational information for the airport. There may be a taxiway that's closed. The radar service may not be in operation. There may be something else. There may be an instrument approach that they want you to expect. And advise on initial contact, you have information, Bravo or Alpha or Zulu or whatever it's going to be, whatever the name is. So when you make your first initial call up to either approach or the tower, you would say something to the effect of Aspen Approach, Diamond Star 141 Hotel Lima, 18 miles to the northwest, inbound landing with Bravo. And that's all you tell them. Then they tell you what to expect, what approach to expect, how to do it, and if anything else has changed, and when to switch over to the tower. So that's kind of how that works. But that's what ATIS is. It is the Automated Terminal Information System. And I'm looking here. The next thing is, how do we get it? We get it over the radio. That's how we get it. So there's going to be a radio frequency that will allow us to get ATIS. I think Aspen is 120.4. So we would tune into that as early as we possibly could. If we can pick it up 35 miles away, we do it. In the terrain and the lower altitudes, it may be closer to 20 miles before you're able to get it. And in some cases, Aspen Approach, if you contact them or they contact you, they will ask if you have the information, and you may have to tell them, listen, I'm trying to get it, but the communications keep getting garbled. So, and that's if you're on flight following, and Denver Center may hand you off to Albuquerque Approach early, and you may not have had a chance to pick up the weather yet, so you just let them know that you'll get it when able. So that's it. So you get it over the radio, and each airport has their own specific weather frequency. The next question is it required for us to use? Only if we want to land or take off. So yes, the answer is yes. Is because when you're getting ready to even taxi in Aspen, the first people that you call are ground at 121.9. And when you're on ground no, I think it's oh shoot, I'm forgetting what it is. No, I think it's 121.9. And you'd let them know, Aspen ground, Diamond Star 141, Hotel Lima at the North Tie-Down area, ready to taxi with Bravo. And you let them know, because that way they know that you have the most current information. If you don't, they may say information Charlie is current. And so then in that case, you'd stand by, listen to Charlie, and then call them back up and let them know Aspen ground, Diamond Star 141 Hotel Lima, ready to taxi with Charlie, so that they know that you know what the current winds are, visibility, sky conditions, temperatures, altimeter settings, blah, blah, blah. Okay, so you've got all that. So yes, it is required to use. What information does it give us? I think I just told you. Okay, so that's what ATIS is. It is very important communications for taking off and for landing. All right, the next question that we have goes down here, and let's take a look here at a displaced threshold. So if we look here at a displaced threshold, remember us drawing these things? This is going to be what a displaced threshold is. So the threshold of the runway in this particular piece, it begins, I don't know what just happened here. I just lost all electrics here. Hopefully that just came back up. Interesting. I'm not sure what's just happening here, guys, but there we go, maybe. I don't know what just happened here. That's odd. Guys, I apologize. I'm not sure what's going on here with the display of this computer. It just went out. And I don't know why. That is very odd. Not sure what's going on here, boys. I do apologize. Wow. This is a first. I'm not sure, guys, if something... Did I lose this one? I've got this one. I've just lost all of my ability to put this screen on here, guys. I don't know what just happened. Well, shoot. I don't know. This is one of those things that's never happened before. Let's hope I can get this back, because otherwise this is going to be really boring. Wow. Have no idea. Sorry, guys. So when we look over here, if you'll remember, this is what a runway threshold looks like. Is that you have something here with the piano keys, then you have the numbers, and then you have the center lines starting here. Anytime that you have more space down here in front of this runway, you may have something here that lets you know that you are not supposed to use that for landing. Now in this case, this kind of looks like runway 33. This is a displaced threshold for landing. You can taxi on this and you can take off on this, but you cannot land on this. To land, you have to land here or further up on that runway. You cannot land here. So that is what we refer to as a displaced threshold. You have hard surface there. You have something else that in an emergency, I suppose, you could use as an overrun if you're coming from the other direction, but they don't want you landing on that. The reasons for that is because it may ultimately put you too close to some obstacles on the way in or out, It could also be that it's not reinforced like the rest of the runway to withstand the impact of a landing. It could be a lot of different things that they have, but that is a displaced threshold. So when you're drawing it, that displaced threshold should look something like that. This again shows a displaced threshold, just like we're looking at here. And in fact, this is what it looks like in Albuquerque on runway 17. You have the overrun area, which I'm trying to find one here for you. The overrun area, let me go back here. The overrun area will look something more like this. And that's the overrun. On this, you cannot taxi on that, so there's no taxi, there's no takeoff. The only thing this piece is here for is for an emergency overrun coming this other direction. So those big yellow chevrons, you don't taxi on them, just like this. That is not for any movement unless it's an emergency coming the other way. All right? So there's that. Now, next question. Draw a hold short line. Well, and I don't know why, but this one was a little bit more difficult than I thought, given the fact that I have two hold short lines actually taped out onto the floor there in the classroom. So again, using your resources, some of you will look back and you will see what that hold short line looks like. On the field itself, it is going to be solid lines. Those solid lines are going to be on the taxiway side. So over here is going to be a taxiway. The runway is over here on this side. So the dashed line side is going to be where you are on the runway. The solid side over there is the taxiway. Why is that important? On the hold short lines, the whole point of the hold short lines is for you to hold short. You always stop your aircraft on the solid side of those lines, whether you're coming or going. So if you're on the taxiway and you're getting ready to enter a runway, the solid lines will be in front of your spinner. And you have to stop and get permission to taxi onto that runway. And you get permission from the tower. Then if you've landed and you're coming off the runway and headed to a taxiway, you come off the runway and you cross on the dashed sides of it, cross the dashed sides, and just like this, I'll try to make this work here, so that you're taxiing off and you cross, and then you stop over here on the solid side and get permission to taxi. So you have to have permission to taxi coming off the runway. You have to have permission to enter the runway when you're coming from the taxi side. So permission to taxi normally comes from ground control. Permission to enter the runway normally comes from the tower. Okay, so that is what a hold short line looks like. On the runway, it is a yellow line, okay, a yellow line on the runway. And in some runways, they will actually put black paint around the yellow to make it stand out more. That's what they've done here on this particular runway, as you can see. On the signs, on the taxiway signs itself, they will be yellow with black marks. But on the runway, it's going to be yellow in a black paint setting. So there's that one. Taxiway edge markings are what color? That's the next question. So if we look over here and we try to find the taxi markings, let me kind of run through here. There's some more hold short lines. There's some more of those painted runway holds, more of the directional signs here. Come on, come on, come on, come on, come on. I'll get down here to it, guys. Forgive me here for flipping through all this stuff. Stand by. Coming through here. Where am I closed? Oh my goodness. Hang on. Goodness. Well, let me just tell you, they're blue, okay? Taxiway lights are blue, so that's what they are. Taxiway lights are blue. I don't know why that, I know it's in here. I know the runway edge stuff here. There's taxi, hang on. It'll say that the taxi lights are blue somewhere back here, but I thought they had a picture of them, but maybe they don't. Anyway, taxi edge lights are blue. Let me go back up here. Okay, so they're blue. Centerline, taxiway centerline markings are what color? They're going to be yellow. Taxiway are going to be yellow. There could be green lights on the taxiway because they're experimenting now with some of the lines, but the markers, the lines themselves on the taxiway are going to be yellow. There will be some differences in lines only because of the fact that they're starting to put lights in there to kind of help guide you where you're going, and you sort of follow the bouncing ball. You know, you follow the green light through there, or if they want you to stop, they'll make everything in red. But that's kind of the way that they do it. Taxiway directional signs are what color? So if we look at taxiway directional signs, let me pull one up here. I think we just saw one here. Hang on, hang on, hang on. Taxiway directional signs. This is a runway sign, the red with the white letters. Taxiway directional signs, stand by. That's another runway sign letting you know that you're entering a runway. Taxiway signs are going to be like this. So you're on Delta here. This is telling you that you're on taxiway Delta, and as you come to this intersection right here, Bravo is going to be one of these two ways. So you would either turn left or right on Bravo, but they're yellow with black letters and arrows. Taxiway marking signs are going to be yellow with black letters, or they can also be black with yellow letters. Runway marking signs are going to be red with white letters, okay? So runway holding position signs are what color? And that I think we see right here. So with this, red with white, okay? This is where they're going to be, red with white letters. So runway red. All right, what is an airport beacon? Airport beacon, let's go back to that. Where did I find that? Was that down here? Hang on guys, sorry. Hopefully it's not making you dizzy here as I flip through this. I'm still pretty amazed that this thing just went crazy there for a second, and I don't know why. So a beacon, an airport beacon is this rotating beacon that will be at an airfield. So if we look at this and we think, okay, what color are they? Well, if you look here at airport beacons, you can see here that for civilian land airports, they're going to be white and green. What that means is that this rotates. So depending upon your position, if your position is stationary, it will rotate and it will kind of flash. It's a relatively narrow beam that emits from these beacons. So it'll be kind of a flash. And so you'll see this white flash, green flash, white, green, white, green. And that'll indicate a civilian land airport. For the military, it's a little bit different because you have two quick white flashes and then a green flash. So you'll have white, white, green, white, white, green. And that is going to be a military airport. Why is this important? Two things. One is that you need to be able to identify these airports from the air in at nighttime or low light conditions. So at nighttime, if you're searching for that airport, you got to know that the world looks a lot different at night than it does during the day. At night, you have black with all these lights scattered all over it. In some cases, without a moon, it may be very difficult to distinguish the city lights from the stars if it's a moonless, starlit night. And it can be a little disorienting. So things look different. Being able to identify that airfield by more than just your navigational equipment can really help you out. Also, if you're doing cross countries, it's nice to be able to know and be able to plot your position on these maps to be able to say, okay, here's the airport over here, and to see that beacon rotating there at night. In the daytime, when weather has gone below standard VFR weather conditions, Then that rotating beacon will also come on during the daytime. And that can also be the thing that can help you find that airport in low visibility conditions. So that's what that beacon is. And I think that that answered the questions that we had there. Now we're going to go back over here to VASI. What is a VASI? A VASI is a visual approach slope indicator. That is VASI right there. If you have anything other than that on what is a VASI, well, that would be incorrect. So where do you find a VASI? You find them at an airport. Normally on the left side of the runway is where you find it. What specific information does it give you? It gives you the visual approach slope indication. So just as this thing is talking about, that's what it does. You've got a couple different flavors of VASI. A VASI can be a 2-bar, 3-bar VASI. And so if we look right here, this is like what we're looking at. What you're looking at here in figure 14-29 is you're looking for these bars over here. And I think I already kind of marked these up here for you. So remember, red, both of them are red, that's low. Both of them are white, you're too high. Red over white, you're all right. And so even if you had here, let's say, even if you had just the regular lights like this, if you had this indication here with the round lights as opposed to like the bars, that would indicate that you're on the glide slope. Most glide slopes are going to be about 3 degrees. And that really gives you about a 500 foot per minute descent. I don't want to tell you that if you followed that in kind of under a low power setting, that even if you didn't pull up kind of and start your flare with that, some cases you can land the airplane. Some of the big airplanes, they kind of set them down like that. You know, the F-18s landing on aircraft carriers, they just kind of a controlled crash the airplane into the runway. But what you do is you follow that rate of descent in until you have the runway made, and then of course you're going to reduce power, arrest your descent, flare, touch down on the mains, let the nose come down when you can, and it's all about energy management. So that's what those are about. So red over white, you're all right. White over white, fly all night. That means that you're high. Red over red, you might be dead. That means that you're low, and low is not a place you want to find yourself coming in and out of a runway in the mountains. So what color are runway, then we ask what is PAPI. So let's look down here and see what PAPI is all about. So here is PAPI. PAPI is Precision Approach Path Indicator. PAPI, Precision Approach Path Indicator. If you don't have that, that's not what PAPI is. Where do you find them? Normally you'll find them on the left side of the runway. What specific information does it give you? It gives you information about your glide path coming into a runway. Again, remember, most of them is going to be 3 degrees, but not always. Aspen is a little steeper than that. But in this case, what you're going to have is you're going to have 4 lights set out there in a row. As we see right here, if you have 2 white, 2 red, you are right on it. 1 red, you're slightly high. 1 white, you're slightly low. And then all red, you might be dead. All white, fly all night. Okay, you got that? What color are runway lights? They are white. What is pilot controlled lighting? Tell me specifically how it works. So if we talk about pilot controlled lighting, is that we look here and it is a way that we have a certain frequency that we have here on the radio. And with that frequency, what you can do is this. As you approach that airfield at a non-towered airport that you're controlling the lighting, pilot-controlled lighting, you do it with the push-to-talk switch on your radio. So you dial in the common traffic advisory frequency. Let's say it's 122.8. When you are attempting to find that runway or find that airport, you want it on the highest the lights there on that runway at the highest intensity available. And so what you do is, when you tune in 122.8, you click the button on your yoke or your stick. It's called the push to talk switch, and you can see them on the J's there in the classroom. They're those black buttons. The red button is the autopilot disconnect, so don't do that one. But the black button, so the black button, and you key or press the button 7 times in 5 seconds. So in this case, you're trying to find that airport. You think you're about 10 nautical miles away. Click, 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 click. That's 7. That will bring those lights up to the highest setting. Ah, there's my runway. Excellent. So now you enter the traffic pattern for that runway, and now here you are on downwind. As you're on downwind, now what you want to do is to put those lights on the medium intensity setting. And to do that, you'll click the mic 5 times. Click, 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 click. That will put it at a medium setting. You lower the lights. Why in heaven's name would I want to dim the lights to that runway a little bit? One of the things that happens is that we don't want the lights to kind of overpower everything that we're looking at and everything that we're seeing here on our instruments. The second reason is this. As you get closer to that runway, the brighter the lights are, the higher you think you are over that runway. And with bright lights on that runway, pilots tend to have a tendency to flare high, and that can be a pretty rude awakening when you slam that airplane down to the ground trying to find, asphalt with that. So you want to dim the lights so that you can actually see the surface of the runway better. So you've now got the airport found. Enter the traffic pattern. You go from the high to the medium intensity setting. Then, as you turn from downwind to base, you're going to set those lights on the dim setting or the lowest intensity setting. You do it 3 times. Click, click, click. That will put the lights on the lowest setting, and you do that before you turn final. You've already got the runway found. You're not going to lose it. It's going to be just fine. And the reason being is so that you don't try to flare the airplane and land that sucker before you get to the runway. So that's what we normally teach when we are teaching how to use the lights for that runway. So that's what PCL, or pilot controlled lighting, is all about. Okay? How would you know if a runway was closed? Well, let's take a look. I think we passed it up here. Okay? You're going to have a big X on that runway. In most cases, it's going to be painted on the runway that you can see during the daytime with a big yellow X on it. If it's a temporary closure, let's say, they will put out a cart or a big machine that's got a generator on it, and they will put the lights out there on that runway like you see there on that cart. So it will tell you that you shouldn't land at that runway because that runway is temporarily closed, or it may be permanently closed. Some cases you just don't know. So that's how you would tell if the runway was closed. Okay? So now, let's get back over here. And the next thing that we were going to do is that we were going to talk about, we'll get back to this here, this information here. How do we speak pilot? Well, one of the things is that you guys have heard me say for some cases years, we pronounce each digit. We also pronounce the letters. And the reason that we do that is so that we don't make things any more confusing than they already can be. So we have an alphabet, A through Z. And it's not as easy as to say A, B, C, D, E. Notice anything in common there from B through E right there? They all have the same long E sound. B, C, D, E, G, T. You get that? And in a radio, when you're listening in a headset, if you have your microphone is not very good, or if you've got a lot of things going on, all of those can sound the same. So the reason that we say something different is so that you know for sure what letter we're talking about. So that's what we use. We use a word for a letter. So with this, A, alpha. B, Bravo, C, Charlie, D, Delta, Echo, Foxtrot, Golf, Hotel, India, Lima. Get the idea? So that's what these are. You can take a look at these and you can see what we have. Now the other thing that we didn't do on here is we didn't talk about the numbers. Numbers are also pronounced the way you might expect. 1, 2, 4, 6, 7, 8. Okay? Those are pronounced the same way that we normally would. But we do something a little bit different for the numerals 3, 5, and 9. One reason is because 5, 9, you hear how that can sound, that long I sound? So we say fife. So to pronounce the number 5, we say fife. For 3, we say tree. And for 9, we say niner. For 10, what do we say? 1, 0. So we pronounce each digit. So for 10, we say 1, 0. It's just like for runway 33, we don't say runway 33. What do we say? Runway tree. What about runway 15? We don't say 15, do we? We say runway 15, right? So those are the letters and the numbers. This is how you speak pilot. Next. What is wake turbulence? Well, let's take a look over here and let's find out what wake turbulence is all about. First of all, when is wake turbulence generated? When do these vortices begin? Those of you that said when the wing is creating lift, give yourselves a pat on the back. Runway vortices exist anytime that aircraft airfoil is producing lift. They produce vortices. What exactly are wingtip vortices? Well, here's what happens, and I'm going to try to draw this on this airplane here. When the airflow begins to flow over the top of a wing, one of the things that happens is that air moves not just over the top, but it moves toward the fuselage of that aircraft. And when that wind is flowing underneath the wing, it flows this way. It will flow away from the fuselage. So now let's think about what that looks like over here. Whoops, not over there, sorry. Let me try this. Here we go. As this air does this little twistoid right here over the tip of the wing. What happens is that airflow difference, faster air moving over the top, slower air moving onto the bottom, low pressure on top, high pressure underneath, high pressure underneath, it creates this twist. So the air will flow out, up, and toward the fuselage like this. So if you look at this airplane right here, it would come in toward the airplane and out. It gets very, very tight initially, and then as the airplane moves through the molecules, then that vortices, that vortex gets bigger and bigger and bigger the further the airplane is away from it, and the more time that wind has an opportunity to unspool. Okay, so that's kind of what happens. So you see it on this imagery here as being very, let me get over here, as it can be very tight at the wing tip, and then it gets larger as the air has a chance to kind of unspool underneath it. So that's how these form, and that's kind of what happens there on that airflow. Try to get that image back. So that's how the vortices form. Vortices for an aircraft are going to be greatest when that aircraft is clean, heavy, and slow. What does that mean? When would that configuration occur? That configuration occurs when you have a great big airplane that is taking off, pulled up their gear, pulled up their flaps, and has a higher angle of attack. You've got a high power setting, high angle of attack because you're slower, you're starting to climb, and your aircraft, the airframe is clean. That's when the greatest vortices occur. There was an accident that occurred, I want to say it was in November of 2001. It was, I want to say it was a Delta Airbus of some sort, I think it was, that flew into the vortices of a departing 747 coming out of New York. The Airbus flew through the vortices of that aircraft, and in the process of trying to straighten up the airplane, the first officer, who was the pilot flying, in essence, and this is going to sound horrible, in essence, he was sawing the rudder so hard that it put so much stress on the vertical stabilizer of the airplane that the whole vertical stabilizer and rudder came off the aircraft. And it was a horrible accident. The airplane broke up in flight on the way down and crashed over Queens, I think it was. You can Google it, you can find out when that was. But that is an example about how monumental that wingtip vortices can be on an aircraft. They are nothing to play around with. And that's why we are very, very careful when we operate around an airport, especially an airport that has large aircraft taking off and landing in front of us. So we want to be extremely careful. Okay? So with this, as we look, you can see that the turbulence or the wake, wingtip vortices or wake turbulence ends when that airplane lands. And it begins just as the airplane rotates. So if we look here at this illustration, this is what they refer to in figure 14.46 as vortices behavior. So remember, you'll bring the vortices with that aircraft all the way down until touchdown. Then on the takeoff run, you have takeoff run here, and when that aircraft rotates and begins to develop lift, that is when the vortex begins. That's not to suggest that there aren't still dangers here on this runway from an aircraft that's taken off, because you can have jet blast, which is different than wingtip vortices. The jet blast are produced from the engines of that aircraft itself. That and again, you can Google this and you can look at jet blast from a 747, and they show a 747 taking off somewhere, I forget where it is, and you know, YouTube or whatever will have this, but there's a truck that is either being driven remotely or they're doing it for the demonstration, and you see this great big fuel truck just, you know, getting blasted down the road, down the runway I should say, from the jets of like a 747. It's again, very powerful. So the vortices can also be powerful here as well. So what does a wingtip vortices do? It can blow a lot of things a little wonky over the runway. So imagine here for a second, if we look at this figure, and it's figure 14-47. So if we look at the top one, here's an aircraft that's landed here, and let's say that it's on that 3-degree glide slope. Normally, this airplane in trail is going to be at least 2 minutes behind it. We have to think about wingtip vortices as having mass, because they sink below that aircraft, and they sink at a pretty good rate. I want to say it's like 500 feet per minute, so they sink pretty well. If you're 2 minutes behind that other aircraft, if you're on that same glide slope, you're going to be just fine, because the vortices will have sunk below that glide path. But if you're a little closer to that airplane and you're low, here's another reason why you don't want to be low approaching an airport, especially if you're following a big airplane, is the fact that you could fly into those vortices. You're flying into a sideways tornado. So what do you think is going to happen? I know. Okay? So if you look here, this is an aircraft that is chosen to land above the vortices of this airplane. So what they want is that if they see the airplane touching down here at the 1,000-foot markers, this next airplane, if they're not sure, they want to come in higher, and they want to land beyond the touchdown point of that other airplane. That way they know they're not going to be flying into the wingtip vortices. The other thing that you have to be concerned with is the wind, and here's why. You may think, okay, I'm okay with the vortices because I'm above it. Well, let's say that this wind right here, it's showing a left quartering headwind. So that kind of pushes this over here this way and kind of gets the vortices out of your way when you're coming in here to land. But let's say for a minute, and they don't have one here, let's say for a minute you have no choice but to land on a runway that has a light quartering tailwind. Let's say that happens. Well, you have the vortices that are out here and they're swirling out here as they come down to the ground. Well, guess what's going to happen? In a light quartering tailwind, it can carry these right over here onto the runway itself, and that could be kind of a bad day. So you have to understand your wind conditions and understand that if you think about these vortices having mass, which is how you need to think of them, and the fact that they're a sideways tornado, if you think of them that way, you're going to give them the respect they deserve. So remember that. That's going to be kind of a thing that'll really get your attention. There is I want to say, another YouTube video that shows a Cirrus SR-22 that is coming into land, and I want to say it was in Erie, Colorado. It's been several years ago. There were some military Black Hawk helicopters operating in the vicinity of that airport. There had been a Black Hawk helicopter that had taken off on a runway there, and a security cam there at that airfield shows a Cirrus SR-22 coming into land, and I want to say it's like 40 to 50 seconds after that Black Hawk took off, and you see this guy in the Cirrus come in. Next thing you know, he's on his back. And it was just the craziest thing. But again, it's not just aircraft that can create these wingtip vortices. Helicopters can do a great job of interrupting the air around an airport as an airplane can. And in fact, here's one that we had out in New Mexico. At Double Eagle Airport, KAEG, there on the West Mesa of Albuquerque, where we used to do a lot of our target practice out there in airplanes. Guess who we shared the sky with out there on certain days? The Osprey, the CV-22. And that aircraft is an airplane and a helicopter combined. And you want to talk about something that'll mess up the air. Those Ospreys are crazy with messing up the air. We used to give 3 minutes in trail after one of those departed or arrived before we would get anywhere near them. If you think about, and you guys all know what an Osprey looks like, Joseph, you built one, is that they have huge blades that they have for the main prop blades, rotor blades, and they have these nacelles that can go up to hover and roll forward to go fast. And those things, when they take off and land, especially if they're taking off and landing vertically, or if they're even doing the slow takeoff and the slow landing, it is truly putting your air in a blender. And that can be just a real bad day. Okay, so that's wake turbulence, how it forms, what it does. You guys got all that. Hopefully you had enough here on these illustrations here that you drew those illustrations. Last question that we have on here, what is EMAS? So EMAS, and we're going to look over here. I'll get to this here. We didn't even go to the communications because we didn't have enough time. EMAS, Engineered Materials Arresting System. What in the name of Orville and Wilbur is EMAS? Well, if you'll remember what we talked about here in these overrun pieces here, here is another reason that you don't want to taxi onto an overrun. You see this area right there? This is an EMAS system at the overrun end of an airport. I'm going to try to blow this up a little bit here. Let me see if I can make that picture a little bit bigger and get over there to it. Stand by. Here we go. Come on, baby. Okay, so here's an example of an airport here in West Virginia that has installed an EMAS system. So the reason for this is this. If you look down here, and you look at this area here, it's a bluff. This airport has been built up here and it sits on this kind of a bluff out here. So it's an elevated airfield around the terrain around it here. So what they don't want to have happen is they don't want to have aircraft that's coming in here to land, and they come through here and they have a problem with the brakes or their reverse thrusters and they do an overrun. They don't want the airplanes, you know, flying down the bluff. So what do? They install this EMAS system here at this end of the runway. So what happens is that it is a series of this kind of this crushable concrete of different layers that they have. And what happens is that as you go through it in like normal braking or whatever, you maintain your center line, more on this in a second, and you drive your airplane through it. And it's like driving it into the mud. That EMAS system will grab a hold of the tires, grab a hold of your gear, and it'll slow your airplane down with minimal damage compared to going off the end of a runway somewhere with a lot of people on an airplane, and you know that's just not good at all. So that's what that is. It's basically it is a disposable, crushable end of a runway that will put your airplane in the swamp and slow that down with that crushable concrete. So when you look at this here, one thing I want to show you is this. Where's the taxiway to come over here and use runway 5? Well, look where it is. The closest taxiway that you have is over here. Well, how do you get over here and take off? Well, you'll notice this little piece right over here. This is what we call a turnout. So what you do is you are going to enter the runway here when you have permission. You'll see the hold short line right there, by the way. So when you have permission, you can enter the runway, you back taxi over here, and then you come back over this way, line your airplane up for takeoff here on runway 5, which by the way is kind of taking off toward the northeast. What you do not want to do is to go past this area here and get on this EMAS surface. It will destroy the surface, and it's like putting your airplane in quicksand. So you definitely want to avoid the EMAS piece there. It's very important that you do that, okay? Because you don't want to mess up your aircraft, and you don't want to mess up the surface there for somebody else who's actually going to need it. And so that is that engineered that engineered materials arresting system piece. They also have some other arresting systems that they have at some airports that are served by the military. In some cases, what they'll do is that they will have an arresting system like they have on an aircraft carrier, where they can pull up a cable and they can grab that gear of an airplane to keep it from getting shot down the bluff or some area there at the end of a runway. Runway 26, I think it was in runway 26 in Albuquerque had that arresting system there at the approach end of runway 8. On this here, so they had cables that they could put up if they needed to slow down an airplane, and I think they had them at the other end as well, because they had F-16s that operated out of there for years. It used to be back in the day they had P-51 Mustangs, which is really kind of cool. And by the way, I did get a note from Mr. Malcolm, who was going to be bringing his P-51 Mustang in for us to see this coming Friday. He's not going to be able to get it here from California in time for school to be out. But I will keep you posted on the next time that Mr. Malcolm is able to get that airplane out here. And if you guys have not seen his airplane, it is absolutely gorgeous. I mean, it is an immaculate reconstruction of an aircraft. So you guys will definitely want to see it, and I will let you know the next time it's in town. He's going to try to have it back out here the 4th of July, so we'll let you guys know. So when you look here, EMAS, that's it. This talks about what EMAS is, how it works, how the construction is, gives you the setback, the arrestor bed, all of that stuff, all of the considerations that a pilot has. Remember I told you about centerline discipline. This is one of those reasons why we always want to make sure that we maintain centerline on a runway. And I'm going to go back over here to this image. When we taxi, when we take off, we must consider it a source of immeasurable pride, not to mention safety, to keep our airplane lined up in the center of this runway. Why do we do that? Why do we do it on the centers of the taxiways? Why do we do it with all of those? Because in some cases our wingspan may be such that we have problems to the sides, and we want to make sure that we keep our airplane in the center. But in the event of an emergency like this, having to use the EMAS system, if you came at the EMAS over here this way, you could potentially overrun the arrestor bed and have kind of a bad day. So you definitely want to be able to keep this aircraft in the center of that arrestor bed so that you can take advantage of that EMAS system. All right, guys. There we go. Again, hopefully you're actually seeing me do this, and this is not going to be a thing, but in the event that it is, there we go. So, guys, awesome. Hopefully I'll get to see you all again. I know this is our last day of class, I believe, but again, you guys come by, say hi, let me know what you're doing for the summer, and hopefully be able to see you guys here just real soon. Okay, guys, there you go. Have an awesome day. Talk to you soon.